Buongiorno. I present from Rome, Italy, the Globolocal project and the use of the parallel globe. That is a tool for working on astronomy in the day, but not only in the day, also with sun and in the open air. With sun, it means that we must wait for a sunny day with no clouds. And it is an ecological aspect of our work, because we must be patient and wait and recognize that we depend on nature. In the open air, it is very important for our health and our wellness that school is also conducted in the open air, in the garden, and not only in the classroom. The parallel globe allows many didactic approaches at different levels with children, young students, and adults, because we know from research that adults also have difficulties in explaining quotidian astronomical aspects. The parallel globe is very easy to construct. We remove the usual terrestrial globe from its stands, fixed and universal, and it is enough to place the globe on a cup. As first, the globe is well oriented with a compass, with the North Pole to the north and the South Pole to the south. A second, our location is on the top. In fact, everywhere we are, the entire planet is below our feet. If I am in Rome, Italy, at 42 degrees north, I put the globe like in the photos. But if I am in the equator, in Kenya or Colombia, the terrestrial axis is quite horizontal. And if I am near the South Pole in Antarctica, the axis is quite vertical. So everybody and every country is in turn at the top of the world and in the part of the globe facing up. We can put the globe on a cup, or we can build a new flexible stand. With this globe, is evident that north-south is different from high-low and from up and down. Instead, the fixed globe makes us think that there is an absolute up and down, and the parallel globe helps us to see that north is a global geographical reference. Instead, up is a physical local one. So we put the parallel globe in the same position that the Earth has with respect to the Sun. The globe and the Earth are in a homothetic position, and the globe assumes the same position of the Earth in the space. So the Sun illuminates 1/2 of the sphere of the Earth and 1/2 of the sphere of the globe, with the same countries in light and in shadow. The parallel globe allows us to see the Earth from outside, because in every moment the model is illuminated like the planet. It helps us to find the connection between the local topocentric perspective and the global geocentric one, and to reflect on an heliocentric global position. So our local position is considered in a global dimension. We can observe on the parallel globe where it's midday and the shadow of a gnomon disappears, where is night or day, where they have sunset or sunrise. We can also see the seasons. Observing the parallel globe several times in a day and several days in a year, we can see which elements vary and which remain constant. If we observe the terminator, that is a maximum circle on the sphere, that separates the light from the shadow. we see the direction of the rotation of the Earth. We can also measure and calculate how many hours of light we have in a day related to the local latitude and the period of the year. Looking at this instrument is very different from studying this phenomena in a book and repeating a phrase from memory. It is much stronger from the point of view of emotion, of astonishment, of memory. The parallel globe lets us travel to all the countries of the world. If we live in the north, we can see what happens in Ecuador or in South America in this moment. If it is day, we can see where now it is night. If it is summer for Italian people in August, we can see where is winter, for example, in South Africa. For this reason, it is an instrument and not just a model of the Earth. It helps us to put questions and to find answers. Why the name parallel globe? Because the axis of rotation of the globe is set in the same direction that the Earth has in the space. The angle between the axis of the horizontal plane is equal to the latitude, and in every point of the planet, the horizontal plane is parallel to the tangent plane of the globe. If we put some toothpicks or pieces of plasticine in a radial position as gnomons, we see their shadows with their direction and longitude with reference to the inclination of the sun's rays. We can put more gnomons on the same meridian in places with the same longitude or on the same parallel in places with the same latitude. With the parallel globe, we can work on common errors and difficulties. For example, we can approach problems with perceptive and cognitive difficulties like why don't people in Argentina fall off? And at the moon, even at a solstice, we can see that the sun is never at the zenith in a lot of latitudes, for example, in Europe, like a lot of young and adults think. Summer is not due to the position of the Earth closer to the sun because we have two different hemispheres that are in different seasons at the same time. Globolocal is a project developed by Italian and Argentine researchers for teaching astronomy, for helping understand astronomical phenomena with attention to different countries in the world, with their geographical and astronomical differences, from the equator to the poles. Usually, representation and models refer to the northern hemisphere, as if it were universal. This is a big problem of power and furthermore causes many difficulties in comprehension of astronomical phenomena for many. On the website of the project, we collect photos, didactical experiences, and the reflections about the use of the parallel globe. The website is now under revision. But above all, the parallel globe returns to each and everyone their position on top of the world. And that is why it is a democratic tool. Democracy means to recognize the dignity of every position of the world and also the dignity of every languages.